Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, one of our friends requested for project E2E overview. So in this video, I am planning to cover all the tools and processes are applicable in the Spark project. So here I will be covering only the theory because I am yet to set up my laptop. Okay. So in case if you have any questions, please put it in the comments. Okay. I will get back to you on that. So coming to the end to end, right. So for whatever project, it starts with the requirements. Like what work you need to do. You should know the requirement. So coming to this requirement, if your project runs in the waterfall model, okay, waterfall model means in the previous versions, currently after like Agile has come now, before that almost all the projects were waterfall model where they follow specific sequence to complete the stages of the project. It will have various stages and phases and it will have long duration projects, okay. But if your project is running in that waterfall model, then you will receive the requirements in the form of SOW or change request or even enhancements, minor enhancements, major enhancements in any of these formats. And if your project is running in Agile model, then I think Jira board is used for handling all these requirements. So for each of the requirement, something called as story will be created in the Jira board. Okay. So Jira is a tool where we can update the details about what is the problem, what is the acceptance criteria and to whom we are assigning this one and when it is getting completed, like what is the start date and end date and how many pointers it will take to complete that particular item, problem statement. Okay. That one such kind of problem statement, one Jira ticket is called as story. Okay. So such stories with all the requirements will be created in Jira. Okay. And in this particular Agile model, right, so we will have something called as sprint. Sprint means in waterfall model we can have the projects, longer running projects, like we can even have 3 months projects, 6 months projects and even 1 year project also will be there for implementing one particular component. But whereas in Agile model, right, it will be like a small, the big work will be divided into smaller modules and each smaller piece will be created as a story and that will be picked up by any of the resource who is working in that project. So it will be like a short duration. How short is that? That is like it differs based on the team members or the team project work, like that. So let's say your sprint is 3 weeks or 4 weeks. Then the piece of work that you are taking from the Jira, right, the story, that will be estimated for how much duration we will take and all. Okay. So that kind of requirements. First let's discuss about the requirements, right. So whatever requirement you are getting from the client or from whoever business or whatever it is, so first that will be checked into the Jira. Like once it is there in Jira only, you will come to know that yes, I have got the work and all the related stories related to your project, whatever work is there, all the requirements will be created as stories in the Jira board. Okay. Jira, Jira board. Then what is the next step, which is the design. Okay. So in the waterfall model, we will have functional and technical design documents which will be shared with the developers or with the leads. Okay. So usually functional documents we receive from the business and usually the leads will be creating the technical design documents. By seeing that what will have these design documents means the functional documents will have what functionality we wanted to achieve out of this problem statement. Okay. Similarly, the same thing using the technical terms, it will be updated in the technical design documents. Like in the functional, you can see only based on the functionality. Like in simple English, you can see, right, like this is what needs to be done. This is the requirement. If you submit one form, then that form should accept only numbers in this field, or only something like that. Okay, but in the technical design document you have to mention what all the code which kind of classes you are using, which kind of functions you are using, what each function does, and if it is having some tables, what is the table detail, what are the table columns, what exactly the length of the fields, like what is the data type of the fields. Every technical detail, every simple technical detail will be stored in this technical document. Okay, once we have these functional and technical design documents, then this work will be assigned to the developers. Developers have to go through the each and every document and note down the requirements manually, or we can have a traceability matrix, which is a document to note down all the requirements, and we have to work on one by one. We have to solve and note down each and every functional piece of the work, and then we have to complete the project. So these kind of things usually will take from 1 month to 3 months to 6 months. That's based on the nature of the work that you are working on. But in agile model, right, we will have some grooming sessions, technical or functional grooming sessions will be there, or you will be given some technical specification, functional specification, and then they will explain you that the scrum master or whoever it is, right, whoever is product manager. So these people will explain you the procedure to what is the requirement, what you have to do, and all that. So this thing will be done in the design phase. Okay, and then coming to the planning phase, so we have the we know what kind of story is there, we know what is the technical part of it, what is the functional part of it. Now we should know how much time it will take, what time it will take to complete this task. Correct. So for that, in the waterfall model we have some estimated techniques like estimation techniques like SMC. Okay, SMC is most popularly used technique, which is like simple, medium, complex. Like, but this is very easy when you have proper experience. Okay, when you have experience, you should know like this kind of work, yeah, this way, this writing this function will take 1 day. Okay, this is the testing we have to do. Okay, this will take 2 days. So with experience you will understand what is the estimation, how many days you can estimate for that piece of work. But if you wanted to go by exactly like based on the formulas, and if you wanted to be very specific and very exact estimation that you want to give, then you can go for the estimation techniques like FP. Okay, function point or something. Okay, FP we say. So such kind of estimation techniques, there are a lot of estimation techniques in the market. You can use that. In the planning of agile, right, agile model, in the Jira itself there is some estimation like how many pointers it will take, that kind of details you can mention in the Jira board itself. Also the team, the scrum team, the agile team, right, the scrum team will have a group discussion to they will summarize the problem statement, and the entire team will have the group discussion like how much time it will take, like what is the estimated value for completing that piece of work. So after the group discussion, everyone will have to put in their estimated value, and mostly picked up like what is the maximum max people selected the duration, right. So that number will be considered as the like story points, which will be like a estimation for that particular piece of work. So like this the planning phase will be done, and based on the like whatever is discussed in the group discussions, that points will be updated in the Jira board. Okay, next coming to the coding, which is the main part of it. So first, for coding, what kind of IDEs we use? IDE means for completing some work you have to do some Spark coding, correct. We are mainly looking for the Spark projects here. So in that Spark project we can use various IDEs. So the IDE is like kind of tool. Okay, it will be in the form of exe. You can just click on that, open, write the code, perform the testing, and then once the jar file is created, test it in the cluster. So that's easy to use. That kind of IDEs are available in the market. Okay, so what are those IDEs that mostly that we use in Spark are Eclipse with Scala IDE. Okay, there is a plugin for using Scala IDE in the Eclipse. Okay, for like Eclipse will be mostly used by Java projects or many other technologies. Okay, but using the Scala IDE plugin, we can easily use the Eclipse for working on Scala and with Spark projects. And then IntelliJ is another very good IDE from JetBrains, and we have PyCharm. So this PyCharm and Spider, from Anaconda distribution itself you can download these two, PyCharm and Spider. These two are very good IDEs, mainly used for working on PySpark projects. Okay, and Eclipse and IntelliJ sometimes they use for Python as well, PySpark as well, but most of the projects Eclipse and IntelliJ are used for Scala and Java related projects. PyCharm and Spider for Python related, PySpark related projects. Okay. Okay, now we know we have got the IDE. Okay, but we should know where is the code exit. If it is a new code, then you have to implement one. I mean, you have to create one. If there is a enhancement on the existing code, like there is a code already but something is not working, you are applying a fix. If there is a code already, if it needs some enhancement, then you are applying for you have to apply for some enhancement. You have to do some enhancement. In such cases, the code should be already present, right? Where is it? For that we have some code versioning tools. Okay, the tools like Git, Bitbucket, SVN, and there are many such things. Okay, dimensions also there are. Most of the Oracle projects they use that. Okay, so we have these versioning tools where our code is securely checked in and already present, the previous versions of the code. Whenever you are working on the new project, then directly you go to the IDE, you work, and while checking in the code, first you create a branch and then you will just check in the draft version of it or initial version of the code. Okay, but whereas if you are working on any enhancements, then you find the correct branch for that project in Git or Bitbucket or SVN, wherever it is, any versioning tool that you are using in your project, right? So that versioning tool, from there you see the branch, you clone that, and that cloned version will be taken into your IDE. Why we have to take the cloned version? Because whatever is already present is the code which is already deployed to production, which means that it is running code, which is the gold code. Okay, so when we are applying some fix, we have to test it thoroughly and then only we can push that back. It is not that easy to just push into production and later on fixing the bugs, because many people will be using the production data, correct? Like the main users, the end users will be already working on that production outcomes. So it's not a good idea to touch the code that is already present in the production. So what we have to do, we will take a copy of that. Cloning means taking exact copy of that and then creating a branch for that. Okay, or creating a fork for that. And you work on the forked branch or the copied or cloned branch, so that whatever you change will be in a separate branch and your production code is intact. Once your current branch, the forked branch, is, after you apply the changes, it will be thoroughly tested in multiple environments, and once everything is successful, and then only it will be merged with the prod branch. Okay, this is how this versioning tool works. So why we have to use versioning tools means, for example, you have got a story which is like maybe very complex story, and that cannot be completed within a sprint. As I said, sprint is the term used for the time duration for completing that work, like in that what model they are going through, the project people. So based on that, each project will vary. One project will take 2 weeks, another project will have the sprint of 3 weeks, another project will have sprint of 4 weeks. That they will decide based on their requirements. So now one particular story is there which cannot be completed within one sprint, right? Then what we will do, we will split that larger story into multiple smaller stories, and multiple people will pick up that story, so that if 4 people are working, then that can be completed within one sprint itself, correct? So in such case 4 people will be using the same code base, but they will be working on different functions. In that case what they will do, they will also clone this production branch, whatever it is, whatever data that is pushed to production, right? That branch they will clone. They will have their own forked branches. They will completely like isolated their own code, and that isolated way they will work on their own codes, and they will finally, all these branches once tested thoroughly, they will resolve the conflicts, and all these will be merged with the production branch. This is the way we can make sure that multiple people working on the same components, they will have their changes intact, but still the same code will be taken care of multiple changes at a time, and finally the merged code will be saved to the production branch. Okay, so for all these kind of things we have the versioning tools. So after setting up your IDE, you have to have the log into one of any of these versioning tools. From there you will clone the code, you work on that. Now you have completed your changes. How will you test? For testing, you have to do the unit testing first, okay, because you wanted to test whether your code works fine or not. In the unit wise, each function you have to test, correct? Each and everything you have to test, and then only you can go for cluster testing, correct? So for that unit testing, again there are some tools like JUnit, PyTest, that kind of tools are available for unit testing. And even for the code coverage, some people use SonarQube, such kind of tools also for code coverage. So what is this unit test? Means you have written a function to find a sum of two numbers. Then you will write some test cases for that by passing some mock integers, like mocked input, saying that 2, 3 if you pass, and you will not directly test the code, but you call that function which is actually performing the sum of the given numbers. So you should have a mocked call to that function, and you will assert the result. Assert the result means if you are sending 2, 3 as input to that finding the sum number, right? So what you can expect? 2 plus 3, 5. So you will assert saying that I am expecting reply as result as 5. So when you call that function by passing 2 integers, it will return some value and you will assert that. Using this way, you can test each function call whether that is perfectly by any issues while calling the function with multiple different various data types, various like values, decimals, everything. Okay, you can test the function thoroughly so that whatever like maximum of issues will be solved out within the your IDE itself. In the IDE itself, you will write the test cases, you will complete the testing, and once you confirm that everything works fine, then you will go for cluster testing. That's when the cluster testing will become very easy for you, because most of the issues will be resolved in the unit testing itself. So you just have to check for any kind of data issues that you will be having in the cluster. Okay, most of the syntactical or any kind of other issues will be resolved in the unit testing. So for that, for Scala or Java projects, they use JUnit, and there are actually many more such kind of things. For example, JUnit you can take, and for the PySpark they use PyTest. Okay, and there are again similar such kind of unit testing tools are available there as well. And next comes the code coverage. What is code coverage? Code coverage means you have 100 lines of code. When you are doing the unit testing, you will see how many lines of the code tested properly. So that is called as code coverage. In the entire 100 lines of the code, how many lines of the code you tested? So what is that? For example, there is a if else condition in your code. So if some country equal to India, perform this, else perform this, there is some if else condition available in this code. When you are doing the unit testing, you have to pass the input, right? You have to mock the input as well. When you say directly, okay, I am passing the input as India, and when you try to test that, then only if block will be tested, correct? Because once if it is the country is India, then that's it, it will never go to else block, it will come out of that loop. So that is where this code coverage will help us to show if any such missing testing clauses happen, like we have tested if by passing the country as India, but whereas we haven't tested by passing the country with some other value, we haven't tested the else condition. So from else, how many lines are there within that are considered as the skipped lines. Okay, so that is where this code coverage will help us. In all the JUnit or even SonarQube or PyTest, everywhere there are some code coverage commands where you can use and get the code coverage for each and every file that is available within the SRC folder. Okay, so when after all this, like first coding completed, then unit testing is completed with all that, then you will check in the code. So before checking in the code, you have to have either egg file if it's PySpark project, jar file if it is Java or Scala project. So egg file, jar file you will create using, there are some commands, right, like clean compile package for creating the jar, then pytest setup.py and bdist egg for creating the egg files. So using these commands you will create egg or jar file, and once it is successfully completed, then you will copy these required files. What are these required files? Egg file or jar file. If there is any property file or any supporting files, all these files you will copy to the cluster, correct? Once unit testing completed, you have to do the cluster testing. So for the cluster testing, you will log in using either putty or some people use Tectia or terminal, item, any kind of session you use for connecting to the Linux box, like Hadoop box or whatever cluster you use. After logging in, we have FTP tools like WinFTP or whatever it is. Using that WinFTP, you will SCP, WinSCP or WinFTP, anything is there, WinSCP you will copy from local to that cluster. You will log into that cluster, you will copy from local to cluster where some specific location, you will copy all the required files from your location to development environment, and there you have the egg file. Using that you will frame one Spark submit command, you will submit the job. Okay, so once that is completed, you are satisfied with the result, then you have to check in the code, correct? So in what is the way to check in the code? In the any of these IDA, whatever these IDEs that you are using, that right, Eclipse or IntelliJ, PyCharm, Spider, Scala IDE, anything is that, go to the main project in the left side, right click and do the like git push, something like that. Some will be there inside the git, you have this check-in and all these things, and similarly for Bitbucket also, Bitbucket check-in, when for SVN check-in, this kind of options you will get it. Okay, for all this you have to set up your IDE properly first. So once you have added the plugins, then you will be able to use all these things, and then once you push the code, you open your branch in the front end to verify all the changes are available there, and then once you are comfortable, you will send that code for review. Okay, you will give that online link and you can raise a pull request and ask for the review to your lead or whoever it is. Okay, so then now you have tested in dev. So now you wanted to move the code to UAT. How will you do that? For deploying from one server to another server, not one server to another, if you wanted to deploy to some server, like if it's dev, then dev, for dev usually we do the normal SCP only. For UAT, SIT you will have SIT 1 2 3 4 5 environments. In that case you will use some pipelines to create the jar from which will be automatically take your code from Git or Bitbucket, and then they will create the jar or egg files. They will copy the code to the given target server. Okay, for this kind of work we have some tools called Jenkins, TeamCity, exactly, etc. Okay, so now what these Jenkins, if you take, right, what these Jenkins will do, already there is a port open for your cluster to the Jenkins. So when you create one Jenkins pipeline for your project by giving the Git URL or Bitbucket URL, Jenkins know that it goes to that URL, it will fetch the required details, it will generate the egg file or jar file. So how it will generate is, we would have written some Jenkins file while checking in the code itself. In your IDE you have to have some code for the Jenkins file to what exactly functionality we have to do while deploying the code. You want to create a jar file, then you have to give the jar creation steps in that. Okay, I mean in the shell script wise how you will write, right? The similar way you have to give all the instructions in the Jenkins file. Based on that file, what this Jenkins will do, Jenkins pipeline, it will read the data from the given Git or Bitbucket repository, and in the target folder wherever we ask to place the files, right, in any of the server and any of the folder, there it will place the data. So once the Jenkins pipeline is successful, you can go and verify in the target server, you can see that all the files are copied there. Once that is done, you just have to trigger the Spark submit job to test whether your changes are working fine or not. So why we have to test in multiple environments? Because in dev you might have done something already, some setup has been already set up, so it will be always successful, but you are not sure whether the same is going to work in production or not. So that's why you will deploy the code to SIT, UIT and many other instances, so that even if you are deploying your code to some fresh instance, if anything is failing, you will know the fix for that. If any setting is missing or any other file is missing, you will come to know before deploying this to the prod. For that reason, every code should be tested in multiple environments. Once all these testings are completed and it is successful, then we will create a final Jenkins pipeline for deploying the code to the production. Okay, this is what will happen. And now we have the code ready, we have checked in the code, we have deployed the code also, but who will submit the Spark submit in production? We don't have access, right? Like only the production support or any such kind of admin team only will have the access for submitting the jobs in production. So what we have to do? We have to send a request to them for scheduling the jobs. I want this job to be run in 9 a.m. in the morning, 9 a.m. IST, okay, or 3 a.m. IST, whatever it is, okay. Now for that we have some scheduling options. So what will happen in this scheduling phase is, we will have lot of schedulers like Oozie, CA7, Autosys, such kind of schedulers are available in the market. So every client will have to have some license for any of these things, and then only we will be able to use these schedulers. So what is these schedulers? The schedulers will allow us to give input to what is the job name, what is the path, when it should run, is it weekly once, monthly once, daily, then it is what time, what is the timestamp, if you wanted to skip weekends, then how to do that, and any such kind of things. Then where should you write the logs, if there are any errors, in which path you have to write the paths, in case of errors to whom you have to send mail. all these details will be there. Like when you create a job, right, for the first time in the scheduler, it will expect all these details from us, so that once we are completed and it is scheduled, you don't have to touch that file again. So in the given time it will start the job and it will update the logs in case of any failures, or if even if it's success also, if you want, there is an option for that, but only in case of failures you want mailer, it will send the mail to you. So those kind of facilities are available in all these schedulers like Woozy, CA7 and Autosys. Like that you have so many, and using all these things you will be able to schedule the jobs. Once this is successful, then that story is completed. Okay, so from the coding to from the checking in of the code, and then deploying, and then scheduling. This scheduling, it is required only for the first time if you are doing on a, if you are working on a new job. The job is already present and you are working on some enhancement, then no need to change the scheduler at all, because that is already present. Okay, and it is already running. You just have to copy the code to production and just monitor for 1 or 2 runs, so that everything is works fine. Okay, this is how the project works. Okay, next time soon I will try to come up with proper tool details, like how it will look like. Even I will try to capture the screenshots and maybe I will show that to you. And sorry for the very lot of theory, because I don't have the cluster setup in my machine. Okay, I hope you got all the tool details, and thank you for watching the video, friends. Please subscribe to my channel for more interesting learnings. Thank you.